All right, guys, here we go. We got our notebook. We're going to open this up to our table of contents. Sorry, I'm a little bit ahead of you here. And we're going to add on the next line the next topic that we're going to talk about. Today, we're going to talk about most of all of our properties of numbers. So properties of numbers, and that's going to go on page 2 and 3. And we're just going to fill out page 2 today. Next, we'll have page 3. Okay, so we have that. Page 1, we had our number types. And if we turn the page, right behind that, we'll have page 2 and then page 3. So on page 2, you're going to grab the next piece of paper that you have in your packet that looks like this. And just like the last one, we're going to do like a backwards book fold on that. So I folded this over already so that you can still see the word properties. And then we have all of our properties listed down the front here. Normally I would make them all little doors, but I wasn't thinking it through. So you don't want to cut into this one. But we're just going to use some tape or glue to put that down here on page 2. Now we can put page 3 in together right now, but we're not going to fill it out yet. This is another one of our properties. So the very next page in your handout or your packet should look like this. So it is still a property, but we're not going to talk about this one yet, although you might remember it. And this is also going to be one of those backwards book folds like this. And then on this one, you can cut each of these lines to make 2 little doors if you want. If you don't, it's okay. I'm going to do it because it's cute. Get a little tape or glue and put that on the back here. Put that on page 3. There you go. We'll fill that one out next time. Okay, so kind of like with the different types of numbers, you guys, there are also properties that numbers follow. We don't often think about it. We kind of just do it. And because we just do it, we often don't name it or talk about it in like, these vocab-y type terms. We just do it because we understand that we're allowed to do it. Now, I like geeking out about this stuff because it's super mathy, but we're going to do our best with it, and I'm sure you'll be fine. Okay, so when we're talking about properties, we're essentially talking about what is allowed to do with numbers and what's not allowed. So one thing that is allowed is kind of the commutative property. So when I hear the word commutative, I think about commuting or moving back and forth between a place. And that's what the commutative property is talking about. It's talking about the order of numbers. Now, sometimes the order of numbers matters, but if I'm talking about addition on its own or multiplication on its own, then the order of those numbers don't matter. If I'm adding 5 and 7, that's the same as adding 7 and 5. It doesn't matter the order. Similarly with multiplication. If I do 7 times 5, it's the same as 5 times 7. So the ordering of those numbers don't matter. That's our commutative property. Another property that we have is the associative property. And when I hear the word associative, I think about my associates, who I associate with. And like who I associate with is kind of like my posse, that's my group, that's my, I don't know what the cool kids say anymore. But when I think associative property, I think about the grouping of numbers. So when I have more than just 2 numbers, like the commutative property maybe I have 3 or 4 or 5 numbers, and I want to group up certain ones. When I'm talking about all addition or all multiplication, the way that I group them doesn't matter. So for example, if I had something like 3 plus 2 plus 5, I might want to group it that way because 3 plus 2 is 5 and then 5 plus 10 is easy, or 5 plus 5 is 10, which is easy, versus something that's grouped like 3 plus 2 plus 5. I'm not saying that's any harder, but doing 2 plus 5 for 7, then plus 3 more is maybe weirder to think about, still 10. But notice that the order of the numbers didn't change, just who I grouped together changed. And you're allowed to do that as long as it's all addition or all multiplication. Now, our identity property When I hear the word identity, I think of this at my core is who I am. And that's true for numbers as well. So the identity property shows a number for what it is. So kind of your OG number stays the same. OG number stays the same. Now this is a little different when we're talking about addition versus multiplication. If I am the number 4 and I need to add something to it to remain 4, I need to add 0. Versus if I'm talking about multiplication, if I'm the number 4 and I need to multiply something by it and remain the same, then I need to multiply by 1. So the idea here is I'm starting with a number and I need to remain the same. With addition, it's 0. With multiplication, it's 1. Now, inverse is kind of the opposite of that. And when I hear inverse, I often think opposite. So the inverse is going to take me from what I am kind of to nothing. But nothing means different things for addition and subtraction. So inverse is kind of opposite. It takes a number to nothing. I hate to use the word nothing, because when we hear nothing, I think we think 0, which is sometimes the case, but sometimes not the case. So it takes a number to nothing. It makes that number go away. And so again, if I'm talking about addition, if I'm the number 4, I need to add something to it to become nothing. And when I'm adding, I do want to become 0. I want none left. And I would need to add -4 to do that. So 4 and -4 will get you nothing. Also, hinting back to math, we hopefully already know the inverse operation of a +4 that I'm adding is a -4, because that gets rid of that number. Now with multiplication, again, it's a little different. If I'm the number 4 and I need to multiply by something to be nothing, I don't want to be nothing in the sense that I'm 0. I want that number to go away, and I want it to be just 1 that I'm left with. And so this one's a little bit trickier. If I need to times a number to 4, if I need to multiply 4 by a number to be 1, I actually have to multiply by kind of a small number, fractional number, one of my favorite types of numbers, fractions, and that's a fourth. A fourth of 4 is 1. If I split 4 into 4 equal parts, and I'm just left with 1. Essentially, you're doing that inverse operation. If you remember again back to last year, if I have 4 times something, I need to divide that 4 to get rid of it. So it's essentially whatever number you have on the bottom and then 1 on top. And then last but not least here are 0 and negative properties. Now, notice that all of these apply to addition and multiplication, but the 0 and the negative property only apply to multiplication. So the 0 property of multiplication says that if I multiply a number by 0, it's always 0, no matter what. And if I multiply a number by a -1, it's just going to be its opposite. So kind of simple properties, but those are things that we want to remember so that we're good and quick at math. And again, these are probably things that you already do. You just don't think about what they're called. So we're going to try some together. And I'm not going to have you guys try any on your own this time. I'm going to actually attach a Google Forms that will be your assignment on a separate assignment in Google Classroom. So we're going to do all these together. Quick. Okay. So we're going to name the property that illustrates, that is being illustrated in each equation. So 9 plus 7, 7 plus 9, same numbers, just different order. When I'm ordering numbers, I'm the commutative property. Now, if you want to be fancy, you could say commutative property of addition, but it's fine, commutative. When I look at the next one, I notice that there are grouping symbols, but I have to make sure that they're grouping different numbers and that the order of the numbers didn't change. So the order is D43, D43. So order is the same. So it's not commutative, but I did group different numbers. Here we're grouping together D and 4. Here we're grouping together 4 and 3, which makes more sense because I can do that. It's 12. I can't do that. So that is why we would want to, oh, I'm writing grouping, but I mean associative. Oopsies. The associative property of multiplication, if we want to be super fancy. Next, I noticed that there's a 0. There is a 0 property, however, that's only for multiplication. So the only other thing that kind of includes one, if we're using like, deductive reasoning here, would be identity. That was the only other one that had a 0 in it. And that makes sense because I started with a number, the number f. I added nothing and I'm still f. So that's identity. It's showing you what you are. You were f and now you're still f. Okay, number 4, we have -1 smashed up against an m, which implies multiplication, and that's just -m. So this is that negative property that only exists for multiplication, which just helps us to know that if I multiply by a -1, we're always just the opposite. If we look at number 5 here, we have NP and PN. Now again, 2 letters smashed like that implies multiplication, and I changed the order of those multiplication tables, so that would be a commutative because we are changing the order of things. Now with number 6, ooh, I didn't even realize I did that. 6, 6, 6. Oh, that's spooky. I had 6. I added -6 and now I have nothing. So it's not showing me who I am, that's getting rid of who I am. That is inverse. When I undo or get rid of is inverse. Next we have 8 times 0 is 0. That kind of looks like the identity thing, but identity means I start with 8 and I end with 8. And I didn't do that. I got rid of it completely. And it's not inverse either, because inverse with multiplication we want to be 1. So this is actually that 0 property that exists for multiplication only. Now next, I noticed the grouping symbols again. So this could be associative, but again, we want to check the order of things. 3, 4, 5, 3, 4, 5. Order stayed the same. We're grouping different things, which again shows you kind of why the associative property is nice. Maybe I don't want to add a negative and a positive. Maybe I want to add up the positive numbers and then just take off a 3. So like I get the 9, I take off a 3 and 6. Now you still get it over here, but maybe this is simpler. Oh man, I used my 4 example here. So I started with 4, I times by a 1/4, and now I'm just 1. That's that inverse property. Now, we can do each of these by simplifying using rules that we understand, using these properties that we understand. So for instance, and we're going to write down each justification, like which property we used. So on this first one, maybe I want to group up some different things here. Like maybe instead of grouping up the A and the 3, we're going to group up the 6 and the 3. Now that 6 is really over 1 because I can always write a number as a fraction. And then I can switch up the order on the bottom because multiplication is commutative. So I can move the 3 and the 1 around. And then the A doesn't really need to be over 1 because you can have the 1 or not. So right here, we didn't really use a property. We just used a fact of a number. But here, we definitely used the associative property. I'm just going to use A for associative because we changed the grouping of things. And then I'm just going to simplify, and we have 2A equals 2A. And so it checks out. So really, that was just associative property. You're done. When I look at this one compared to that one, I notice that the letters are all in the same order, but they're grouping up different things. So if I want to make this first equation look like the second one, I just need to change where my grouping symbols are. And then I have it. And when I change up grouping symbols, I've used the associative property. So same thing on that one. Associative property is so handy. And then last but not least, this is a little tricky. So I don't even see a 12A over here. However, hopefully we remember like terms that we were talking about the other day, and I can get these two A's together. So if I kind of first change the order of things and put this 5A closer to that 7A, I've used the commutative property because I swapped the order of those two numbers. And then if I regroup things that are alike together, so the 7a and the 5a get grouped up and not the 4, then I've used the associative property, which allows me to group different numbers together. So I changed what I was grouping. And then finally, I can simplify because these are like terms. If I have 7 A's over here and 5 A's over there, I have a total of 12 A's plus 4, which checks out with that second equation. So these are a little strange down here, but as long as you can kind of identify and use a property smartly, then you should be all good. So try the homework assignment, email me with questions. Hopefully it goes okay.